All right, hello everyone. So today we're looking at a derivative of a composition of two vector valued functions. We've got f, which goes from R2 to R3, and it's defined as f of xy tangent inverse of xy, e to the xy, and cosh of quantity x minus q root of y. All right, and then we have g, which is defined from R3 to R2, and it's g of u v w. First function is u plus v plus w, comma u squared minus w squared, for this, lack of a better word, second function component, put it that way. And one thing you should always check when you're taking your, when you're asked to find the chain rule of a composition, the range of the inner function should have the same dimensions. In our case, g is the inner one. The range dimension, which is 2, should have the same range dimension of your domain for your outer function. So 2 and 2 work out here. So yeah, always look for that, because if you don't have that, then you can't possibly do a derivative because this composition isn't defined. Okay. All right, so how do we go about doing this? So we're going to use the chain rule. And the chain rule for vector valued functions and actually scalar valued functions as well says the derivative of a composition is equal to the derivative of the outside times the derivative of the inside. Now, when we mean d, it is a derivative, but importantly here, it's a matrix as well. And the first thing we're going to start is to show how to compute d of f of g of x, like the derivative of the outside. Okay. So we're going to take a look at f, and as you can see, f consists of 3 component functions. Let me call this one f1, f2, and f3. And you've got, 2 variables here. And we're going to make a matrix, and the size of this matrix that we're going to be looking at is going to have 3 rows and 2 columns. Okay, 3 rows because of each of the functions, and 2 columns because of the number of variables, the input. And yeah, I can make a column f1, column f2, row f1, row f2, row f3, and then column x, column y here. In particular, what we're going to do is specifically is we're going to put the partials of each of these functions f1, f2, f3 with respect to x and y. So this would be change in f1, change in x, change in f2, change in x, and then this is going to be change in f3, change in x. And for y here, we're going to have a change in f1, change in y, change in f2, change in y, and then change in f3, change in y. So again, 3 rows because those were the number of our components for their functions, and 2 columns because of the number of independent variables. And that is what we would compute as d of f of g of x. Now, one thing that you technically need to do here is once you figure out these partials, you have to replace the x and y with what x and y are functions out of. So in our case, x and y are functions of w, u, v, and w. Okay, this would be x, and this would be y. So you technically need to do that. However, because these problems get rather complicated with all the computations, we'll just leave them alone with the partials, and we'll just make a note of what u, v, and w, x, y equal in terms of u, v, and w, in this case, or whatever variables you have. All right, so now we're going to compute dg, and I'm going to do this in a very similar manner. I'm going to go ahead and take a look at the number of functions we have. In this case, the 2 components, that's g1 and that's g2, or if you prefer to call them x and y as well. But I think it's more standard to write them out with the little subscript notation that I have. And yeah, we have 3 variables here. So that means I'm going to have 2 rows, and then I'm going to have 3 columns. And this would be, for this first column with u, this would be the partial derivative of g1 with respect to u. then the partial derivative of g2 with respect to u going on to the v column, and then finally the w. All right, so we have that, and your final answer here is when you put these two matrices together, which would be this right here. Copy that. And then we'll paste this over here. Fit? Yes, this will fit here. Okay, yeah, all right. So sorry, I ran out of space there. But anyways, that's what df and dg would be here. And yeah, your answer would just be this product. And this matrix is 2 by 3, and this matrix over here is, I'm sorry, it's 3 by 2. I apologize. 3 rows, 2 columns. And this matrix is 2 rows, 3 columns. So the point there is that you can do the operation, which is a 3 by 3 matrix, as your result here. All right, so that would work out. And in case you're interested in what the actual values are, this is what I got for df. So you know, I highly suggest you take the partials when you have time on your own, and you can verify them with what I have here. And this is what I got for dg. So essentially you would just multiply those two results together, and that would be it. All right, thank you for your time. I hope this helps.